I'm going to go over how to calculate the angles in our triangle here. The first thing we're going to do is we're going to label some points, and so I'll label this point A, I'll label this point B, and I'll label this point C. I'll then want to divide this triangle into two right triangles so that we can use our tangent trig functions to be able to calculate it. And so I'm going to draw a line straight down from point B. And then I can go ahead and mark this as a right triangle. All right. And so since we have right triangles now, we can then calculate the angle at point B and the angle at point C. The other thing we need is we need some information about the size of our truss system. And so I'm going to go ahead and draw a line down here from point A to this midpoint. I'm going to say that that is 7 inches. And I'll put a dimension line for it. Okay, and then from that midpoint where our right triangle is created to point C is 3 inches. So I'll go ahead and put in 3 inches, and I'll put a dimension line. The last dimension that we need is the overall height of our triangle. So I'm going to draw an extension line out from point B and an extension line out from point C, and the overall height is 7 inches. So then I'll go ahead and put my dimension line in. Okay, so once we have our triangle labeled and we know some of the distances involved with those right triangles, we can go ahead and solve for those angles. And so I'm going to solve for angle A first. Okay, and so to solve for angle A, we're going to use one of our trig functions, and we're limited on which ones we can use. We don't know the length of the hypotenuse of our right triangle, so we can't use sine or cosine. So we're stuck with using the tangent function. And so the tangent of theta is equal to the opposite over the adjacent. So it's equal to the opposite side length over the adjacent side length. We can go ahead and then substitute in those side lengths. So from point A, the opposite side is this one here. It's 7. The adjacent side is this one here. It's also 7. So then I can rearrange my equation. So angle A, or theta, is equal to the inverse tangent of 7 divided by 7. Then all I have to do is get my calculator out. I can take 7 divided by 7. I get 1. And then I'm going to hit second on my calculator to use the inverse tangent. And I get 45 degrees. And so what we've just done is we've calculated using some trig functions. This angle is 45 degrees. All right. So now we can do the same thing for angle C. Angle C, again, we don't know the length of this hypotenuse, so we have to use the tangent function. And so I'll say the tangent of theta is equal to the opposite over the adjacent. Substitute. Tangent of theta is equal to the opposite, in this case of the angle, is 7. It's the height of the triangle. The adjacent is this one here. It's 3. Rearrange my equation. Theta, or angle C, is equal to the inverse tangent of 7 divided by 3. Take 7 divided by 3 on my calculator, hit second and do the inverse tangent of that, and I get 66.8 degrees. And so angle C here is 66.8 degrees. And that's how you calculate angles on a right triangle.